So while my presentation is getting up on screen, I'll just do a little introduction. My name is Justin Mattson. I'm a developer advocate here at Google working on Android. And up front, I just want to thank you all for your interest in Android and letting me be here and do all the cool stuff that I get to do. And so a couple of months ago, my manager said to me, "Hey, do you want to give a presentation at Google I/O?" And I said, "Yeah, that'd be great. What's the title?" And he said, "Debugging Arts of the Ninja Masters." And I thought, all right, no pressure there. And so for today, this is our agenda, and debugging isn't the title of my presentation, but I assume that everyone here has an idea of how to do basic debugging, stepping through code and such like that. So that's not what I'm going to cover. I'm going to cover tools that you can use to diagnose and solve some of the more subtle debugging issues that you may encounter. And one of these that I'm going to focus a fair deal on is performance, because poor performance is a bug. No one plans for this, no user wants it, no developer intends it. So today we're going to start out with what I'm calling the tool tour of 3 tools from the Android SDK that you may or may not be familiar with. Even if you are experienced with them, I think you may find some things here that you didn't know were there. I certainly discovered a couple of things in the process of creating content for this session that I wasn't aware of. And after that, I'm going to go on to some real-world usage of these tools in situations that I've encountered. And I think that'll be the more interesting part of the presentation. And after being on the spot for 45 or 50 minutes, I think it's only fair to turn the tables around and put you guys on the spot for a little pop quiz to see if you can find the bugs or find where to start looking for the bugs. And then fair is fair, so a pop quiz for me, Q&A. We've got a lot to cover, so let's get started. I'm going to start out talking about logcat, and some of you may be thinking, well, why are you talking about logcat? This is a pretty basic tool. But I can't emphasize enough how important I think using logcat during your development is. It's really a tool that provides you some insight into what's happening in the system, and if you use it with your programs properly, it'll give you an overall picture of how your program execution is going. This dialog is probably the most dreaded on the Android platform. Your app has crashed. And unfortunately, this dialog provides very little other information to you or the user why this has happened. So the first place to start looking is actually logcat. And in logcat, you'll often see an error message like this. In this case, I happen to be doing something incredibly silly with the URI that I was trying to fetch. But beyond providing you just the forensic information of what went wrong, logcat you can also think of as your news feed into the system. So it's going to provide you with information about your application if you choose to put it there, and I encourage you to do so, about other applications that have intelligently decided to put information there, and finally about the system state that may impact the execution of your program. This is a slide that I actually didn't have time to take out, but we don't have time to cover. So here's a simple piece of code that I want to use to illustrate how logcat can be helpful. I'm basically reading a URL here. So I'm starting a new HTTP client. I'm getting the content of the response, and then I'm reading it and just discarding it. Now, I never really expect to encounter either of these 2 exceptions under the assumptions that 1, my network connection on my device is up, and 2, my server is up. So let's just take those for granted. In this case, I tested the code 100 times on the emulator. It worked perfectly every time, and so then it was time to put it onto a device. When I put it on the device and looked at logcat, this is what I saw. Exactly what I didn't expect. I'd gotten an I/O exception. Now, my personal first reaction is to overreact and start looking at my code and trying to figure out what I've done wrong. Luckily, this time I decided not to do that, and instead look back in logcat to see this message relating to the Wi-Fi service, which had kicked in. And what had actually happened here was that my device was asleep before I started running. I started running my program, and in the process, Wi-Fi woke up and associated with an access point that it knew and that it connected to. Well, the problem is that, of course, all your sockets are going to break. You can't fail over from the cellular network onto this Wi-Fi network that T-Mobile or Vodafone has no idea about. So logcat in this case was my news feed looking in, and the system told me this change has happened, and the result was affecting my program in a way that I'd never expected. So I didn't spend forever trying to chase after a problem that didn't exist, just deal with it. Next to the dialog that your application has crashed, I would say this is the second worst dialog to see on Android. And this goes a little back to what I was saying, that no one designs for poor performance. Users don't like to wait for things, and really I don't think that they should have to. So again, the first place that I started diagnosing this problem was to go to logcat. And in there I saw this, which was rather suspicious. Lots of garbage collection all going on in a single process, which in this case turned out to be my process. And so just keep this in mind. I'm going to go deeper into this example later in the presentation. So like I said, logcat is a news feed, and it's full of information. Sometimes it's full of way too much information. So one of the ways that you can cut through the jungle of messages that you see in logcat is with filters that you can supply to the program. You simply specify the filter as the tag and then colon the severity. And the tag is whatever you specify in your code, and the severity is whatever severity level you put it at. I'll note that this ordering of tag and severity is actually reversed from the way it's presented in logcat, which presents severity and then severity slash the tag. Another note is that when you specify severity this way, you're going to get everything that's above this threshold that you specify. So if you specify warning, you'll get errors and warnings. In order to make best use of the messages that you're putting out from your program, use a strategy that I like to call smart tagging. So for any reasonably complex Android program, you're going to have different logical components. Maybe you have one component that deals with your data model and another component that deals with synchronizing your web service. It doesn't make sense to tag all your log messages from your program the same thing, because then they're not going to be meaningful. But you also want to make these tags related in a way that can be expressed in a regular expression, so that you can do easy filtering and get all the messages related to your program, or, if you want, then you can go down and drill into the specific component. Now, like I've said, logcat has a lot of information in it, and it can be tempting to generate spam. So I encourage you, when you're considering what to put in logcat, to be precise. So log just what you need, events that are interesting, not every event that comes along and you're unlikely to ever be concerned with. Be concise in that print out something that encapsulates exactly what's happened in the least possible information. I've seen several instances in logcat where the information printed out is an entire email or entire web page that's loaded, and that's not going to actually be useful to very many people. And finally, because logcat is a shared medium and everyone has access to it, be privacy sensitive. Don't print out passwords or credit card numbers or authentication tokens, which is also stuff that I've seen in log messages before. You don't want to be the source of a privacy leak. So, in summary, logcat is a basic tool, but it provides you a lot of power, and I don't think anyone's above looking at logcat and the information that it can give you. After logcat is TraceView, and TraceView gives you a graphical representation to look at your performance profiling data that's really powerful. So when you're tracing your program in Android, it's going to record every method and function entry and exit point. It's going to record, when these events happened and therefore how long execution took. And then TraceView will provide you a timeline and a call tree that you can navigate through to easily figure out, which methods are being called in which order and from which other methods. It's really a must, I think, to use TraceView for any developer that's serious about performance, and I think we should all be serious about it. I'm going to go over some examples of this later, but sometimes you may think, oh, I'm not doing anything in my code that has a significant performance impact. It's just plain code. But there are some innocuous-looking calls out there that turn out to be not so innocuous-looking. And they're really easy to spot in TraceView. It's a very powerful tool, and take advantage of the power that's afforded by it. And finally, because code is never fast enough. We've seen this many places in many products around Google. When we make products faster, we make the latency lower, usage increases. People like speed. So starting tracing in your application is actually really simple. You have two options. You can start it in code. So here you just call debug.startMethodTracing and then stop method tracing when you're done. I'll note that there are separate calls for tracing Dalvik code versus native code. So here in the top example, I'm just tracing Dalvik code. And then you can also start it from the command line. The disadvantage there being that it's a less granular experience. If you want to trace just a small section in code, then you really want to start and stop method tracing in the code. But of course, the advantage of the command line is you don't have to modify the actual source and then remember to take that debugging code out. And so these commands will control debugging for the entire virtual machine. And by that, I mean, remember that in Android, each process has its own virtual machine that it executes within. So you're not starting it just for an activity or just for a service where you call this. You're starting it for your entire process. As a result, you're going to generate a lot of information really quickly. And to help deal with that, just trace what you need. And finally, like I mentioned, tracing has a big impact on performance, and that's why you want to remember to take any debug, or anytime you start tracing in your code, you want to make sure to take that out before you ship, because performance is going to be multiple times slower while tracing is running, simply because the system is gathering a lot of information. So, for example, in this time when I was tracing, and I'm tracing over about 20 seconds here, so 20,000 milliseconds, I think this trace file was around 8 megabytes. So data accumulates very rapidly. And this is the top part of TraceView, the execution timeline. So along the left, you have the threads that are executing, and like I said, along the top, the time that they're executing in. TraceView also gives you the ability to look at individual methods and what their parents and children are, and navigate quickly through the call graph. Because when you identify a performance problem, it may be with a method that you've never heard of, so you need to figure out where in your code this is being called. You also note that the methods are enumerated. So they're enumerated in the order that they're originally called. So thread.run, not surprisingly, is really the first method that's called here. And they're also color-coded. These color codes will correspond to colors in the execution timeline. You can note the big green blob on thread 14 there that we'll actually talk about a little later. A quick note about some of the statistics that are provided. Most of them are pretty obvious. I just want to make sure it's clear what inclusive and exclusive execution time mean. So inclusive execution time is all the time spent executing a method plus its children. And exclusive is simply the time spent executing code that exists solely in that method and not counting any time from descendant methods that are called. So like I said, the source of your performance issue may not actually be in your code, but it may be somewhere else. And to get to the bottom or to the top of that, tracing through the call tree can be very useful. So I'm just going to show a quick example here. So I can click on the down arrow there and see where this method was called from. It's called from fetch URL. Go up further to parents, and I could also then go and navigate down the call tree into any of the children. TraceView is a really powerful tool, and it affords us the ability to optimize reality. I myself have spent plenty of time over my career agonizing and designing really complex data structures, only to find out in the end that this data structure is used in less than 1% of execution time. So I encourage you to take advantage of TraceView, and therefore you can design sensibly, build a proof of concept, test, and then figure out if you need to spend hours and hours developing a wonderfully elegant, highly efficient data structure. So TraceView will help you look at the execution code of your program. But another big component of Android applications is the UI. And the UI can easily get more complex than you might imagine. And Hierarchy Viewer is one way that you can deal with identifying this complexity, and once you've identified it, look at solving it. Hierarchy Viewer gives you a graphical depiction of the UI tree from the point of view of the layout system. And so we're going to navigate this tree a little now. Each node in the tree can be double-clicked on, and when you double-click on that, it's going to show you the UI represented by that subtree. And you can see it on black or white backgrounds. Notice that this UI element has a black background native to it. I can look through further the UI tree here, go down to see some of the children, and then maybe click on another child node over here. And again, investigate, does this element have a background to it? As it turns out, this has no background, or it's transparent. In addition, Hierarchy Viewer will show you lots of information about any individual node in the tree. So here you can look at all the properties, as well as many of the responses from essentially the getter methods of that view. And then because hierarchies are often large, down the bottom corner there, you can see a zoomed out view of the entire UI tree. When you're looking at Hierarchy Viewer, there are a couple classes of conditions that I often see and can indicate that optimization is possible and recommended. So the first group I want to talk about is what I call infertile parents. So this is a layout or view group that has no parents or a single parent. Why do I need a linear layout that has a single child that is a linear layout? Did I say a single parent? I meant a single child. So why do I need a linear layout that has a single child that's also a linear layout, that has a single child that's a relative layout? The answer is that I don't. So, this is ripe for optimization here. The other set is something that I call clones. And so this is parents that have children that are the same type that they are, or have children where the children are the same type. So an example, again, would be, a linear layout parent that has two linear layout children. There's probably a way to combine these or to convert them either to a relative layout or a table layout. And then the other example I was talking about, if you have some layout that has two relative layout children, well, relative layout siblings are very uncommon to be necessary because the data is inherently related. These conditions sometimes result from having our layout broken into multiple pieces, which is sensible from a design and coding perspective. It makes dealing with the UI simpler. It keeps the layout files on average smaller. The problem is that then we usually put a view group, so some kind of layout, as the parent of this component of the UI. And then when you plug it into your UI, you get this container that you didn't really need. You just put there so that you could build this file that you were just going to incorporate into your UI. And the answer to this is to use the merge tag. The merge tag is a placeholder layout that says, whatever my children are, just inject them directly into whatever view group I'm being included in. So the merge tag essentially goes away when you include this layout into another one. Okay, so enough of talking about tools. Let's see some usage of this. And so looking at code, is kind of like traveling along and visiting different towns. And so in my travels, I've accumulated some tales. And the first one that I'm going to call Betrayal, which is nice and kind of, intrigue. It is kind of intriguing. Anyway, so the first couple examples here are going to come from when I was looking at the Google Finance application. So that's Google's Finance client for Android, which now includes all these improvements. And what I was really focusing on was trying to optimize startup time, because the app startup time wasn't as good as we wanted it to be. And startup time is particularly important because this is the first experience your users will ever have with your application. And they may decide at that point never to use it again. But beyond that, it's also the first experience they have when they decide they want to start a new session with your app. When they haven't opened it for 2 days, and they open it again, and they go, oh, I'm opening this slow app again. So anyways, this first impression needs to be snappy. So when I started looking at the performance and tracing in finance, this is the execution graph that I saw. And immediately I see this big blob of color, and I think, wow, what is that? And furthermore, why is that running on the UI thread? So you can see it's on the thread that's labeled main. So this is the UI thread, which always needs to be responsive. Something's running for 2 seconds on there, blocking the UI thread. And it suddenly made sense to me why, when I was using finance, I was frustrated at startup. And the only thing I could think that could take that long was that someone had done a network request and forgotten to move it off to its own thread. I was then very surprised to discover that this had nothing to do with a network request, and that the method that was being shown there is something called get time zones native. And I thought, well, one, why is this taking so long? But then, I'm not doing anything with time zones. Why is this even being called in my code? Well, luckily, TraceView will provide an answer for me. So I can trace up, and I see some more stuff about time zones, and then something about date formats, and further up, more stuff about date formats. And finally, I get into my own code. So, all right, something about date formatting from my own code. Where's this coming from? So it was time for me to look at the code. And as it turns out, in the finance UI, there's a little timestamp in the top right of the UI that denoted the last time that data had been loaded from the server. And to create this little timestamp, we were calling dateformat.format. A seemingly very innocuous call. This really shouldn't take very long at all. It should just happen right away. As it turns out, it takes about 2 seconds to run. And this is what was blocking the UI thread. So the story has a happy ending. The solution was just, move the call to its own thread. And also, because I didn't think this was a very important part of the UI, make it less important. Let other stuff go first. And the result was much better perceived startup time. Because now, and I say perceived startup time because I'm not actually avoiding any execution here. I'm still doing everything. But I'm putting it off, and I'm also not letting it interfere with the UI. And so, in order to lower priority, all you need to do is set the priority on the thread. So the key takeaways that I want to express here are trust no one. Just because you think it's a safe call that doesn't take very long doesn't mean that it's a safe library call that doesn't take very long. Talking to one of the engineers that actually worked on implementing this, what's happening is we're loading this giant database of every date format ever known off of a file somewhere and pushing it up into the Java layer. And this is what's taking 2 seconds. And it's actually 2 seconds in real time, not debug time, because this is a native method that we're looking at. Secondly, a little profiling can go a long way. No one had done profiling on the finance app, but after about 5 minutes, you could see very easily that there was a problem. And finally, that priority matters. This little part of the UI was secondary to the user experience. The most important part of the user experience was getting updated quotes on the screen as rapidly as possible. It's nice to know when they came from, but it's more important just to have them. So, traveling about, it's best to find the shortest point from A to B. However, that's not always the route we take. So, this next example is also from finance, and now I'd seen an obvious performance issue in the execution timeline, but that was really the only one that jumped out at me. So after that, it was time to go into the method information and see what I could learn about what methods were taking a long time to execute. So I started out sorting by exclusive execution time. So again, this shows just the time spent executing lines of code within an individual method. And so that means these are the methods where your code is spending your program is spending most of its lifetime. And good targets to look for when you're looking for inefficiencies here are methods that have a few calls, because then you have fewer code paths to worry about making sure that your changes won't interfere with. And ones that are obviously a long running time, because you want to get the most bang for your buck. And once you've identified your targets, see what you can do about reducing or eliminating the use of them. So this is what I saw. And you can see my friend up there at the top, get time zones native, still there. And there are a bunch of methods that really can't be avoided, probably string.characterAt and JSON tokenizer. This is all necessary. But going down further, I see bitmap.nativeCompress. And I go, well, this is only called, it looks like twice, and it's fairly expensive because sorted by this, it's like number 8 or 10, something like that. So let's see what's going on with this method. And before I jumped into the code, I decided, take a look around in TraceView. Use TraceView to let me use TraceView in order to learn what's happening before I jump into this code base that's relatively foreign to me. So to do this, start out and make sure that I'm zoomed in on the right method there. So bitmap.nativeCompress. And then I'm going to go and see who calls this thing, because I don't really know where the call comes from. So I go up, and we're adding something to the cache, and more information about adding to the cache. And this is coming from result available from a call to get a news item or get a chart. Okay, so I have a general idea of what the progression is here. And then I'm going to zoom in on the timeline here in TraceView, make sure I'm centered on the right function again. And so this is going to expand out the timeline for me. And then I can look and see what's being executed before and after. I'm going to look at the before first, so I'll move it over so we can see the method name. And there's a call at the top you can see to bitmapfactory.nativeDecodeStream. This series of events immediately strikes me as a bit odd, because it looks like what's happening is I'm decoding a bitmap, and then I'm encoding a bitmap. And I thought, okay, and this is also around network fetching. Am I converting image sizes on the client? If so, we really need to fix that. It turns out that the answer is not quite that. So I dove into the code, and this is kind of what I found. It's taking a long way to go from one point to the other. So what's happening is I'm downloading a response and parsing out the data. Part of that parsing is to create a bitmap that I'm going to display on screen, so for a quote or something. Also going to display the other quote information. Then what's happening is I'm compressing my on-screen bitmap so that I can add it to the cache. Now, it's a roundabout way, but you can easily see how you get here. You start out and build an application, and then you think, okay, we're going to display the data on screen, and a little later you think, wait, we should cache this data so we don't have to download it every single time. Okay, we'll cache the data that's on screen. And so you end up going much further and through many more lines of code than are necessary. When the better thing to do is to take a step back, evaluate how the code is operating, and implement this little fix, which is read the response, take the image data, which is in the same format that we were caching anyways, take the image data and cache it first, and then from that image data, inflate your bitmap that you're going to put on screen. And then, you can go ahead and discard the base image data because you no longer need it. So the effect of this looks fairly small. I reduced about 2% of startup time. But again, this is debug time, and this is a native method. So it resulted in a larger real-time improvement. The key takeaways here are big is beautiful. Go for the largest targets first. It's the most bang for the buck and where you'll get furthest with your effort. Before leaping into the code, especially if it's a foreign code base like this was for me, use what TraceView affords you and look at where the calls are coming from and also what's executing around the call that you're interested in, both on the same thread and on different threads if you need to use that to get an idea of what's happening. And finally, 3 rights can make a left. Iterative development can lead us places that we didn't expect to go. And it's always a good idea to take a step back occasionally and see if there's a shorter path. So the next little tale I'm going to call packing mistakes. So sometimes when we're going about in our travels, we repack our suitcase, and some things don't get ordered the way we expected them to. And I started out looking for a problem. I'd sorted by exclusive execution, and I'd seen what was in the execution timeline. So now I'm going to sort by inclusive. So this will sort by the most expensive methods, in total time for the system. And this amounts to something like a breadth-first traversal of your call tree. So you can imagine if you have a tree outlining all the calls that are made, the most expensive ones are going to be at the top. The parents will always be greater than their children. It's not precisely what it is, but it's along those lines. So in this case, again, I'm going to sort by inclusive execution, and I'll see some stuff that I really can't avoid related to strings in the system and whatnot. And then there are some things that maybe I can avoid, but there are lots of calls. And I want to look for something that only has a few calls. So luckily, I see this get news items JSON, which only has one call, and it's taking a lot of my time. So what's making up the time in this method? Okay, so I'm fetching something from the network, and it's talking about a result being available, which is great because I'm kind of already familiar with this code. So I can click down and see who else this method is calling. So again, it's something about adding an item to the cache. And this is called from a network fetch. And I notice this callback result available from the network fetch. So at this point, I have a rough idea of what's going on. I'm fetching something from the network on one thread. So I've probably got kind of a network worker thread going. And once I've got that, I call some callback method that's resulting in the data being added to the cache. And taking a look at the code, this is more or less what I found. So what I've got is I'm starting a new array, which is going to be my list of processed or downloaded items. And then I've got a list called source that I'm reading. So I'm downloading each of these items one at a time and adding them to the list of things that's been downloaded. And then I'm doing a callback on them to say, OK, your data's ready. Do whatever you want with it. In this case, it's going to be added to the cache. What immediately strikes me as odd, though, is that I'm adding the items that have been downloaded to a list. And I'm processing this list each time I'm downloading an item, meaning the first item in the list is going to be processed n times if there are n items in the list, and the second one n minus 1, and et cetera, et cetera. So this seems wrong. It's possible there's a scenario where this is right, but it seems odd. And I look back over the code, and indeed this was odd and a mistake that was added when the exception handling code was refactored. So the simple fix is to move this outside of the fetch loop and have it run after. So obviously this results in fewer calls to the callback methods, and it decreased startup time by about 5%. And this time it's really about 5%. And, oh, wrong way. So this story taken with the others, I just want to say that there's no single angle of attack in looking at problems you may be experiencing with your code. There are multiple angles, certainly from the performance perspective, and they're all valuable. And also that sometimes when you're looking to improve your performance, you discover other things along the way. In this instance, this bug wasn't causing a crash in the program, but what if I was now suddenly fetching 100 news items instead of the 5 or 6, and this callback was being executed, that many times? So it revealed a bug that could have been tomorrow's crash. Next in my traveler's tales is I'm going to talk about consolidating containers. So when you're traveling, sometimes you end up with a lot of little suitcases, and it's time to turn them into one big one. And so we're going to look at hierarchy viewer here and analyzing a UI that's become overly complex. And I just want to say again that UI is code too. We often don't think of it that way because it's specified in Android and XML. But it is on the same level as the Java code that we're writing for the platform. This is a little bit of the UI from the Google Scoreboard application that I was looking at, and it seems pretty simple. I've got 2 rows of data, and then some other data on the left-hand side, or I'm sorry, on the right-hand side. It's not quite in rows. So it turns out this has a rather complex view tree. And it doesn't seem like it really needs to. And you can see a couple of the cases that I was talking about here before where I've got clones where a linear layout has a linear layout as a child, or infertile parents. And looking at this data, I thought, surely this can be turned into a relative layout. Surely this can be made less complex. The first step to doing that is defining the relationships that exist in the UI between the data. And I have to give a proviso on this slide. I was having lots of fun with Keynote transitions, so I used as many of the cool ones as I could. So just bear with me. So the element that I'm going to start with is in the top left. And there's nothing here because we're looking at a baseball score. But if this were something like tennis, there would be a player ranking or something like that there. So I'm going to define this little piece of the UI simply to align with the left-hand side and the top of its container. That's its relationship to the container. My first fun transition. Then the team name is its relationship to this area is that it's to the right of it and also aligned with the top of its container, so to be part of this top row. Now, the next UI element is actually not strictly related to the team name. It is the score for the team, but this is actually related to data for the game. And it's an important, little distinction about this UI, that the right-hand side is concerned with the game, and the left-hand side is concerned with the team itself. So this is specified as being related to the top of the container again, but this time it's related to the right-hand side of its container instead of the left-hand side, with a generous padding margin to allow room for other elements. And along the bottom here, you can see this is pretty similar with cool transitions. But something I'll note is that I've specified this second row. I want to make sure that it is horizontally aligned with the top row. So I've added other specifications to make sure that the left-hand boundaries of the UI elements are aligned. More stuff that you'd expect. And then, like I said, this data on the right-hand side is really related to the game itself and not the team. So this score the score detail area, which is who's on base, is now defined in a relationship to the score status, which is what inning we're in and the count. So now that I've defined all these relationships, I can go and codify this in XML. And the great thing is that I went from a hierarchy that looks like this, it's 5 levels deep, to a hierarchy that looks like this. 1 level deep, in terms of hierarchy viewer, something that's just beautiful. And now you may be asking why. It looks the same now as it did before. So what's the difference? Who cares? Well, design flatter hierarchies for what I call aerodynamic performance. The UI will draw faster. In this case, the drawing, I think, improved by around 7%. And also, relative layouts, when you can use them, have a lot of other ancillary benefits. One, they adapt better to their environment. As the container, grows for these UI elements, the elements inside the UI will just automatically adapt. And secondly, using a relative layout really makes you think about what are the relationships in my data? How is my UI related? Where do these pieces of data belong? And it's a great, and useful exercise to go through that. So key takeaways, layouts are code too, and they evolve and are subject to all the same necessary rethinks as other code. And also that linear layouts are almost seductive in a way. They're simple to visualize and deal with, but they're also overused. And I think we at Google have to take some responsibility for this, actually. Almost all of our examples are written with linear layouts, and we should probably change that to encourage developers to use other layouts. And finally, because layouts are code, they're going to get overgrown. They're going to evolve and kind of turn into mutant monsters sometimes. So take a minute to tame them. Finally, I want to go back to something from earlier in the presentation. I'm going to label it squeaky wheels this time. So if something's being noisy in logcat, there might be a good reason for it, and there might be something that needs to be fixed. So this was for some code that I was using for an internal little toy application that I was writing. And it was taking much longer than I expected, and I found out that it was mostly due to garbage collection. To my rescue came a part of DDMS that you can use in the standalone version called Allocation Tracker. So it does very much what the name indicates. It will track memory allocations and tell you where they came from. Just select your process in the left-hand side of DDMS, which is not shown here, and then click Start Tracking, and then get allocations when you want to look at the allocations that have been made. And this is what I saw. A bunch of allocations all from the exact same place in my program, where I was reading a URL. And what I discovered when I went back and looked at my code was that I was using code that I'd imported from another program. A much simpler program, very, very specific purpose. And so what I'm doing here is I'm opening a URL, and I'm reading it chunk by chunk, in small chunks, 384 bytes. And each time I read, I add a little more to my response buffer that I'm reading. So this was fine for its original intent. I was only intending that this read a couple kilobyte responses, but it had outgrown its usefulness in this case because I was reading much larger ones. The fix was pretty simple. First of all, I'm reading much larger responses, so try to read in larger chunks. Secondly, take all the chunks together and then assemble them into one full response at the end and return that. And the result was, my program got quite a bit faster because I wasn't spending all this time churning through memory. And the key takeaways here are that reused or prototype code is great for its purpose. Leave yourself a to-do in Eclipse to change that later on. And also, if you know that your code was only designed to operate within certain tolerances, use some log messages or maybe even go as far as throwing an exception if the code is used beyond its design tolerances. And so those are my traveler's tales and hopefully a diverse tour of the sorts of things that you can do with just a few very powerful tools in the Android SDK. So I, again, encourage you to exploit those tools heavily to build better programs. Now, I've been talking for 47 minutes and 33 seconds. So, pop quiz for you guys. So if you think you know the answer, we will dispense with the microphones. Just raise your hand and I'll point. I was looking at some code that I'd written and I saw this. Stack Overflow error. It's very curious. It sort of appeared out of nowhere. Couldn't figure out why. And it went on and on and on. And so the question is, what's going on here? Ideas? So the suggestion was the UI is too complex, and this is indeed the answer. Now, I've only, this is a little bit of a trick question because I didn't give you direct tools in this presentation to figure this out. But the first place to start with this would have been Hierarchy Viewer. And this is actually something that many developers have experienced as we're making the transition from 1.1 to Cupcake, is that we've changed the UI layout code, which can result in some view hierarchies that were exceedingly deep, no longer working in Cupcake. So the next quiz is, let's say that I have these two UIs, and they look the same, but they perform somewhat differently. You'll see that the list on the left is quickly outpacing the list on the right. And so the question is, well, one, either where should I start the investigation of what's going on, or two, directly, what's going on here. So let's start, where could I look for the investigation? Yes? So the question was, what kind of adapter am I using for my list view? It happens to be an array adapter here. So the question was about the images for the thumbnails. The images are actually all the same, and so there's no overhead for those essentially.
How complicated is your list item layout?
The question was, how complicated is my list item layout? It's not that complicated. I made it complicated enough to give a nice differential for this example, but I can tell you that the layout is defined in XML and is identical for the left and right. Yep. The question was, am I updating all the rows instead of just the visible? And the answer is no. Yep. Did I add some debugging code and forget to take it out? That's a really good guess, but no, actually. It would actually be much slower if that were the case. Yep. Question was, do I convert views? And that's the answer. No. In the right-hand example, I'm not using convert view. I'm inflating a new view each and every time my adapter is called. In the left-hand side, I am converting the views, and the result is that the UI is 30% faster. So, this is the solution. A great place that this would have become pretty readily apparent is in TraceView. In the get view call, the get view call would have been taking a lot longer on the left-hand side than on the right-hand side. That's the pop quizzes that I have for you. So let my pop quiz commence. And I will preface this by saying a couple of things. One, if I don't know the answer, I promise to furrow my brow thoughtfully, stroke my chin, and get back to you. Two, please use the microphones. And three, if you want to start talking amongst yourselves, if you wouldn't mind just taking that out in the hall so others can hear the answers to the questions.
Hi, can you use those debugging tools like TraceView or Hierarchy View for marketplace apps?
I'm sorry, for marketplace apps?
Yes, apps user download it from the marketplace.
So I think with hierarchy, so the answer for Hierarchy Viewer is no. I believe the answer with TraceView is yes, because you can turn on debugging for the VM from the command line. But you may need, although I guess I'm not entirely sure, because you may actually need root access to turn on debugging from the command line. What's that? Yeah, so I guess I should say if you have a developer phone and you're using Hierarchy Viewer and you're downloading apps that aren't forward locked, then yes, you should be able to see it. Yep.
Is there any penalty for using the log? So logcat, all of the log.e, log.d?
I mean, no method is free, but the overhead for the log is fairly minimal. A lot of the impact and reason I ask people to be careful in the information that they're putting there is that it stays a meaningful and useful resource for people.
Is that something you should remove before releasing production code?
That's up to you, but it can be useful to have it out there in production code. I mean, in our production devices, our logcat messages are on there. You might want to cull them down. But if you can convince a user to install the SDK and connect it to ADB, you might get some interesting information about why your program's not working.
Thanks.
Yep.
I've had some issues with uncaught exceptions in my app out in the wild, and the problem seems to be due to intermittent network activity.
Okay.
I'd like to reproduce that in the emulator, and I was wondering if you had any suggestions on how I can bring my interface up and down in the emulator to reproduce networking going down.
Well, so I think actually in the emulator there are options to do flaky connection mode, essentially.
There's lag and speed. There doesn't seem to be any options for
I thought
flakiness.
You could specify packet loss. So let me let's talk after here and give me a chance to look at the emulator man pages, because I thought there was a way to do that. But,
Thank you.
Yeah.
I was wondering if. Oh, I'm sorry.
Sorry, I saw a big. So let's go over here first.
Yeah, question. If you mentioned applications being used maybe beyond what you intended them for and conditions like that,
Sure.
That might not happen until after you've shipped it because you don't know that's going to happen. What technique could you use to evaluate that kind of thing from a customer that might call you and say this thing is running slow and you're trying to figure out if it's something they're doing different?
Well, I mean, there's nothing inherent to the system that would allow you to do that. I mean, hopefully in this case, your test cases cover the usage scenarios. Although, obviously,
it didn't, right?
Right. Obviously, that's not always strictly true. You know, so there's nothing that I can recommend from the platform. The best recommendation that I can give is that, you know, you may want to write out essentially a log file to the SD card. Mm-hmm. And then, again, if you can convince your customer to connect to their computer and pull this log file off and get access to it. But, yeah, unfortunately, there's nothing inherent in the system.
Thank you.
Yeah.
So my question was if there are any plans to add an ability to Iterate to post a stack trace to the developer's email. This is one of the problems that commercial apps have. You deploy it, you're really good, but you miss something, and you simply cannot reproduce that problem. So next to that force close dialog button, there should be
Right,
possibly an option.
so basically automatic bug reporting is what you're asking.
I guess not automatic, just the user should have the option to post it.
Right. So the answer is that there are no specific plans right now to do that. It is a request that, you know, we get a lot. So, and I think, you know, bringing it up to us and keeping it conscious is the best way to do that. So it's just a matter of priorities because, you know, it seems like a feature that would be useful. There may be reasons that I don't know that it's not there, or it may just be time at this point. So, I mean, it seems like a reasonable request. I'm actually going to...
If I could just do a follow-up to your question.
Yeah.
A quick and easy way to deal with that is to use thread.uncaught_exception_handler. Just catch the exception, post it to your server, and you'll be able to get it that way. You can't use any of the Java mail stuff to mail it, but you can post it to your server. Just make sure you call the default uncaught exception handler when your exception handler runs.
Great, thanks. Yeah.
Logcat is available for the native code also. So similarly, I wanted to know if TraceView is also available in some way to debug in the native code.
Yeah, so like I mentioned before, there are separate methods. There are separate calls to enable dialog tracing versus native tracing. So if you go ahead and turn on native tracing, you'll see that in TraceView too. If that's all the questions, I'm done with 1 minute and 30 seconds left. Thank you, everyone.